OCR A, A-level physics. This is my second video about capacitors. Now, look at this fantastic animation here. What's going on? So this capacitor, we're connecting it to a power supply, and the capacitor will charge up. It'll charge up very quickly because there's not a lot of resistance in that circuit. And then we switch it over and we connect it across a bulb, and the bulb flashes. Flash. So the capacitor charges up quickly and then the bulb flashes. So what does this show? This shows that capacitors store energy. Yes, they store charge. They also store energy. Now, here are some everyday examples of capacitors storing energy. The flash of a camera. You want a quick burst of energy, lots of light. Whoosh, yeah. Now, you've only got like a little battery in there. So what you do is you charge up a capacitor, and then the capacitor discharges very quickly to give you a very bright flash of light. A defibrillator, give me 100 joules. Okay, so that charges up as well, and then you get a burst of energy when you need it. And then the bug zapper there, that just runs off a little battery, but then a capacitor charges up and the bug comes along and zap. I was tempted to do a taser as well on that one. Now, the equation for how much energy they store. Remember that it's the area under this graph. Yes, so I've got a graph of charge against voltage for a capacitor. Remember, it's a straight line, and it's the area of the triangle. Why? Because if you imagine we split it up into rectangles. Now, for each little rectangle, the energy transferred is W equals QV. So if it's a very small, thin rectangle, we assume that the voltage is constant. And so for a little delta Q, the area of the rectangle is delta Q times V. And so the total area of the triangle is all of those added together. So the total energy transferred when it charges up is a half QV. Now we also have that Q equals CV. So if we do a bit of substituting, we have these equations here. So the energy stored on a capacitor is a half QV, or it's a half CV squared. I would say that's probably the one that pops up most often, a half CV squared, or a half Q squared over C. So take your pick. I mean, learn them all. To investigate the energy stored on a capacitor, so look at this circuit here. We've got a capacitor and a power supply, and we can charge up the capacitor and then we can discharge it through a DC motor, and then the DC motor lifts up a mass. Okay, and then the idea is that the higher the mass goes, the more GPE the mass gains, then the more energy the capacitor stores. And what you should show with this is that the energy stored, if we're talking a half CV squared, then the energy stored is going to be proportional to the voltage squared. So if you double the voltage, the mass should go up 4 times higher. Yes, if you double the capacitance, and you can do that by putting 2 capacitors in parallel, yeah, then it will double the height. If you double the voltage, it'll go 4 times the height. So this is a nice little experiment you might do to investigate the energy stored by a capacitor. Here's a little sum for you to do. So have a read, get it done, and the answer is 10.1 centimeters. However, the mass only rises 6.2 centimeters. Account for the difference. And the difference should be pretty obvious. It's to do with the efficiency of the DC motor. DC motors like this aren't particularly efficient. This one is about 60% efficient, which is actually pretty good.